Thank you for the introduction. It's great to be here. Nicer weather than it is in the UK, so I'm glad to be here, and I'm looking forward to the day. So the slight change in the title of this, there was a slight request change to focus just on technologies and regulation. So this presentation basically focuses on technology and regulation. A very quick slide about Transforma Insights. We're a firm of industry analysts. We spend our time advising technology vendors, end user adopters, and the community on emerging new technologies and what can be done with those technologies, particularly from a commercial sense, and how they can impact business. But enough about us, and on to some of the technologies that are changing the IoT right now. And the first one that I want to highlight is non-terrestrial networking. And this is something which impacts particularly third generation partnership, so the cellular operators, also LoRaWAN, so there's direct communication from devices to satellite. And one of the things, if I got a little diagram here, little stylized version of a car which leaves cellular coverage, it goes outside an area of coverage and basically operates via roaming to connect to satellite. Now that's a slightly medium-term view. Right now, what's live and what's implemented and just about becoming operational in certain locations is a much lower data version of that. So the LPWA equivalents, the NB-IoT and the LTE-AM, so low-speed stuff. Medium term, though, the vision is that there will be reasonably high bandwidth, so 4G plus type connectivity direct from a car to a satellite or from whatever device it is outside of areas of cellular coverage. That basically unlocks global coverage or proper global coverage with no not spots for cellular technologies. And there's three real opportunity types associated with that. There are NTN-Centric connections, connections that really wouldn't exist without that opportunity to fall back to satellite, and those could include things like livestock monitoring in moderately remote areas. So they can either, the connected cow can either connect to a terrestrial network or a satellite network. There are overspill connections, so something like a connected car, which most of the time you'd expect to be within an area of terrestrial coverage, but might stray outside of that, well, then it can bounce to satellite. So there's that kind of overspill. And then, of course, there's the traditional satellite markets, which can now be addressed with 3GPP or cellular style standards connecting via satellite. So three opportunity types. And as I say, ultimately, this is going to evolve to speeds sort of 4G plus, not full 5G capabilities probably, and operate effectively as roaming from terrestrial to satellite. So that's quite a big impact. What does it mean in terms of applications? And what I've got here is kind of a little matrix. So non-MMTC, this is the higher speed cellular connections. MMTC, these are lower speed LPWA type connections. So the NTN-Centric things, the things which really need connectivity via satellite, you've got things like UAVs and supply chain monitoring, container tracking and fishing vessels. On the overspill, so these are the things that typically would be terrestrially connected but might stray to needing satellite connectivity. You've got things like vehicle head units, e-bikes, vehicle telematics, and so on. On the lower speed category, it's things, theft monitoring, clearly quite useful to be able to connect to satellite in that case, automotive batteries, e-bikes, etc. And then on the lower speed, things that really require a bounce back to satellite or some facility to fall back to satellite. You've got livestock monitoring, stolen vehicle recovery, environment monitoring, and so on. And you'll notice that this says 3GPP NTN. What I've actually done is I put a little yellow dot. That's a LoRa color yellow dot, LoRaWAN, because LoRaWAN is particularly applicable in those cases. And you'll observe that LoRaWAN doesn't support the higher bandwidth stuff and basically doesn't support the things that might overspill, because LoRaWAN is effectively a fixed type technology, so it's fixed low bandwidth. It operates more in that bottom left-hand quadrant. So that's kind of what the opportunity looks like. Sticking with cellular, there's another technology, 5G RedCap. You'll be hearing a lot about RedCap if you've not already started hearing a lot about RedCap, but very soon you'll hear a lot about it. So there's a stack here. This is the 4G stack. You've got the traditional NB-IoT, LTE-M, and then various categories of LTE. And what we've got now is we've got Release 17 RedCap, which is effectively these categories of 4G dropped into a 5G environment. There will be another one coming along, which is a lower bandwidth version, and reduced complexity, reduced cost, etc. And effectively, that's what this technology is. It's 5G with reduced complexity, lower power consumption, and lower cost. It is effectively 4G capabilities dropped into a 5G world, and that's extremely useful. The main benefit is the future-proofing versus 4G. So if 5G RedCap does broadly what 4G could do, one day those 4G networks are going to get turned off, and it's going to be a lot longer before the 5G networks are turned off. So this is lower cost, simplified, and future-proofed, and it's the future-proof which is the real benefit versus 4G. The catch with that is it does depend on a 5G standalone core network, and those are not rolled out everywhere yet. And it becomes an opportunity potentially to upsell some of these lower bandwidth connections as well. Another question mark, as I mentioned, it depends on the 5G standalone core. Another question mark associated with that is roaming, because roaming in 5G world has not yet been resolved. There are no standards agreed for supporting 5G, full 5G roaming. You can get 5G on your handset, but that's 5G in the RAN. 5G in the actual core network, that has not been agreed and standardized yet. Another one, again, sticking with cellular, SGP32, that's one of the industry's favorite acronyms at the moment, and it's almost impenetrable. What it actually means is it's something associated with eSIMs. This is for managing eSIMs, and you'll be aware of travel eSIMs, which you can pick up on your handset, so you have a local connection when you go to wherever you're traveling to. This process is the equivalent for IoT, and it's more complicated, but it has no human in the loop. And what that means is that it can be done entirely remotely and done to a device from a remote location. So you can manage the connection on that device without needing to access the device or touch the device in any way, which makes it highly suitable for IoT. And that's particularly relevant for things like point-of-sale terminals or maybe automotive connections, and allowing those things to find the best connection that's available at the best cost. And what that tends to do is it's more lightweight than preceding standards, such as SGPO2, which was a sort of older version intended to support IoT. It does bring in a role for an eSIM orchestrator. So there will be somebody who effectively controls those devices. So it's not like an a mobile network or a mobile virtual network. You've got somebody who's sort of standing one level above that, who's steering the device, the credentials or the network credentials on the device, and steering the networks that it connects to, sort of a level above mobile network provider. So there's a new role there for eSIM orchestrator. Although it won't be a free-for-all, there will be some limitations on who can get access to these different SIM profiles from an operator. You won't just be able to dump all your devices onto an AT&T network without first agreeing that with AT&T and getting the necessary profiles from AT&T. So it will be managed and controlled, and there will be operator guardrails. But it's a much more flexible environment, which drives a need for more flexibility in middleware, which I'll come on to in the next slide. And that is something which is just about coming to market now. There's a lot of talk about that, so expect more impact from that, quite a lot more in the next few years. Connectivity management platforms, traditionally these things have been So these are about managing connections principally on cellular networks, but I'll come to how that's extending. So typically what they've done is they've interfaced into the core of the network, and they've provided a user interface so that people can control and manage and monitor SIMs and connections on the network. That's extending so that these things are now much more frequently providing a substitute core network, which gives them a completely homogeneous environment, which they can completely control connections on, and abstraction across multiple different connectivity management platforms. So you might have someone like Symmetric has recently cut a deal with Vodafone where Symmetric becomes the single pane of glass into all of Vodafone's connectivity management platforms and the connectivity management platforms of any partners that Vodafone might agree to work with. So that all gets abstracted up in that case by Symmetric. And the other thing that the folks at Symmetrics would do is full abstraction. And this is really interesting because here we're talking effectively about cellular connections. And when we start talking about full abstraction, you're talking about LoRaWAN connections, Wi-Fi connections, satellite connections. And what you can then do is you can control a device, not a device on a network. And what that means is you can manage a device with a unique device identifier, and the attributes can be whether it's Wi-Fi connected or cellular connected or satellite connected. And that is a much more effective scenario and a much more effective situation to be able to manage things like firmware updates and security, etc., because you're managing the device with how it's connected as a secondary consideration. Up here, you're managing a device on a cellular network, and if it bounces onto a Wi-Fi network, well, it disappears. You don't know anything about it. You do when you have full abstraction. What that means is that tracking of devices can interface into enterprise systems, like, for instance, ServiceNow and asset registers and so on. So you really get quite a different dynamic here when you get into full abstraction. That's a very interesting development. I spent a lot of time talking about cellular. I should spend a little while talking about LoRaWAN as well, clearly, because the environment we're in. This is LoRaWAN's development roadmap. It's available at that link if you want to have a look at it. I've just pulled off some of the highlights, really. But I think the key message is that LoRaWAN is developing with a different dynamic. The standard is effectively evolved and stable. They're not going to go changing it like turning off 2G and forcing you to use 4G and then turning off 4G and you have to use 5G. That's not the LoRa way of doing things. It's a much more stable standard. And what they're focusing much more is bringing that closer to end users and closer to end user use case rather than more broad enablers as might happen in the cellular world. So there's some application-specific developments. There's two ways of interworking with a couple of smart metering standards, a way of interworking to support RFID over LoRaWAN. Again, that's bringing the technology closer to an end user need. And also, of course, there's non-terrestrial networks. I've talked a bit about that. Mobile devices and LoRaWAN relay to really push the connectivity into places that aren't connected to a terrestrial network. Geolocation, firmware updates over the air, and multicast device to device, allowing for standalone networks which are not connected to a wider LoRaWAN network. So there's quite a lot going on there, but quite a different dynamic to the cellular world. Another key to develop, or key to highlight, is AIoT. And there's a lot of AIoT happening, a lot happening in this space. And AIoT happens when AI exists on an IoT device over here. So you could have an AI engine on a video camera. Separately, you could apply AI at the edge or in the cloud, but in AIoT, it's particularly impactful because it allows for increased performance, better privacy, security, and reduced operational costs. So, for example, in the case of a video camera, you could set up and you could say, well, just send me an alert if somebody appears or a human being appears in the view of this camera, and then you get an alert. And what you've done is you can hugely reduce the amount of load placed on a communications network, on a connectivity network. Rather than streaming out a video feed, you're just sending out a signal if it sees a person. And that kind of dynamic means that many more business cases cost in, as in locations where you can justify the cost to put a device to detect whether people are there or not, and potentially you could connect that via satellite or even LoRaWAN. It doesn't need to be a high bandwidth connection anymore. So AIoT is going to be very impactful. It's very complicated because to manage AIoT properly, you really need to draw elements from an IoT solution stack and an AI solution stack, and those tend to operate in different ways because AI tends to be very agile, fast iteration, fast updates, and dependent on homogeneous environments. That tends not to be the way that IoT works. So it's complicated, but there's a lot of opportunity there. We've done some forecasts, some incredibly detailed forecasts of about 270 IoT applications, and we think that by about 2033, there's going to be about 23% of IoT devices will actually have AI on board. So that's pretty significant, frankly. It's worth highlighting that not all AIoT is the same. So this is a random picture, and just illustrating, different ways that you could apply AIoT to that picture. The first thing you could do is you could just say, does this image contain a person or not? That's great for a security camera. If you've got a remote location where there shouldn't be people and you see a person, you just want to know whether there's a person there. You could detect, so you could say, how many people does this image contain? That's a more complex task. You could segment them and track the movements of those people within the image, and that involves identifying them and keeping a consistent identity and watching how they move and interact. That, again, much more complicated. Or you could identify and say, well, who are these people? And that would probably require access to data in the cloud. There's privacy requirements, data sovereignty requirements, and much more processing. So these all count as AIoT, but up here, this is an incredibly simple solution which probably could be supported by a battery-powered spiking neural network, whereas this is, well, it's not. You need access to a consistent power supply and a lot of processing power and wide area connections to get access to the remote databases and so on. So very different. AIoT, again, contains a lot of different flavors within it. The last thing that I want to touch on is regulations, because regulations develop slowly over many years, but recently regulators seem to have found their mojo. And what I've got here is this will be too small to read, certainly at the back. I'm finding it challenging, but. This is a list of themes that tend to recur in regulations. So in artificial intelligence, it's things like explainable AI, fairness, consumer labeling, accountability. In IoT, it's things like secure by design, requirements around passwords, software updates, modification of data sharing, and so on and so forth. Hyperconnectivity, it's things like national roaming and availability of spectrum for private networks and so on. So there's a lot of themes there that tend to arise in regulations around the world. So that's a particularly complicated and fast-evolving space. A few key regulations that are worth highlighting, particularly from a European perspective, the Cyber Resilience Act, which basically mandates that software, IoT devices must meet certain security requirements. And one of the key requirements being to update the onboard software. European Data Act is around sharing data between different providers. NIS2 is around vertical security, and of course you've got the EU AI Act, which is going to be challenging. Frankly, that one's not been entirely thought through properly. but that's going to severely limit what can be done with AI in the EU. A lot of these focus on software, onboard software versions, keeping that software up to date. The software bill of materials, knowing exactly what software is on a device, and security. That tends to be a key theme. And this is just an example of regulations, standards, and other guidance from around the world on that specific topic of software updating. And you'll see, there's about 20, 25 there. And I think there are some which didn't actually make it onto the slide. So you've got quite a few things out in the US. Some of these are regulations, some are standards, some are other guidance like codes of best practice, etc., or voluntary codes. So there's quite a lot in the US, Brazil, and so on. You've got you've got European level regulations and specific regulations that then extend or provide additional constraints in specific countries, typically based on country experiences and key areas of focus within those countries. So, for instance, the Dutch had an experience with their social security scoring systems, which has led them to be particularly focused on the fairness of AI systems when they're applied to assessing people. And they have regulations which extend beyond what might be envisaged by the EU. So a lot of regulations to contend with, and this is only ever going one way. There's only ever more of these coming along. So conclusions. Significant changes are afoot. Currently, wide area wireless IoT is in a period of change. It's been in a period of significant change for a long time. Right now, I think there's more change than usual. Really, quite a lot of moving parts to what's going on. Satellite still very definitely an unknown quantity. Everyone regards it as an opportunity, but if you actually talk to these people who are, the big operators who are putting in place satellite arrangements to support their terrestrial networks, and you say to them, what actually is the opportunity? They don't know. They won't take a view on it. They just know it's kind of something they have to do. And frankly, they're right about that. They do have to do it, because if they don't, their competitors will, and they'll lose market share. They really have no choice, but they don't know what they're going to make out of it directly. Technology vendors, there's a consistent theme about technology vendors making changes that bring their propositions closer to end users and closer to the business dynamics of their end user adopters, rather than just saying, here's my technology, use it if you want. They're trying to get much closer to the end user need. So that is definitely to be applauded, and it's about time, frankly. Regulators, as I mentioned, they're catching up. That's moving quickly now. You really need to focus on regulations if you're doing particularly anything multi-country, because that can add to solution fragmentation. LoRaWAN, it's well established. It's cementing its position. Really just a range of tactical incremental developments. And adopters will need to raise their game as well. Technology developments ease the path to adopt IoT, but regulations, as I mentioned, are developing quickly and can result in different constraints on a solution in different markets around the world, and making that generally more complex to manage. So that is it. That is what I had to say. Just a final one, which is that you can go to our website if you want to. There's a free access there. If you sign up to an Essential, you can get a range of our content, and in fact access the regulatory data, the regulations that I told you mentioned earlier. There's about 400 different regulations there just sitting on the website, which you can search through in various ways. So encourage you to go and have a look there. That's all. Thank you.